Hey y'all, so I wanted to create a video that will hopefully help you with this modified question that we had from the packet. All right, now in the packet, this original question was essentially if I start a ball at a given height, right? Don't worry about the number here, I added that on later. So if I start a ball at a given height and I release it from rest, will it have enough energy to make it through the loop? And the answer, if you haven't done it already, try it first. The answer is no, right? If I release it from rest here, then at this point, it has a certain amount of gravitational potential energy and no kinetic energy, right? Because I'm releasing it from rest. So what happens? The temptation is to say, but yeah, it has enough energy to get back to that point. Well, it does have enough energy to get back up to that point, but let's say just for a moment that it did get back to this point. Okay, it gets back to that height. How much kinetic energy does it have? Zero. What's going to happen to a ball if it has zero kinetic energy at this point? It's just going to fall down, right? So even if we said that it could make it to that point, it wouldn't have enough energy to make it through, because in order to make it through that loop, it needs to have some kinetic energy there. Why? Because of the force of gravity that is acting there, right? It needs to have enough velocity at this point that it follows kind of projectile motion at the top of the peak in order to be able to make it through the loop, right? Now, with that having been said, what really would happen? Well, really, it would kind of go up here, and as it gets up here, it wouldn't have enough speed to continue up the loop, and it would actually fall off the loop like this, and so it would have some kinetic energy going this direction, but if it has kinetic energy at all going that direction, then it's not going to be able to have enough gravitational potential energy to get up to that maximum point. And so therefore, I'd have both types of energy here, not enough gravitational to be up at the top as it is moving this direction. So my ball would actually do something like this. It would leave the track at that point and fly off kind of in that direction. All right? So the first answer is no, it would not make it through the loop. The second question, which is the one that I asked in your homework tonight, is, okay, well, what if this loop was 10 meters tall? Exactly how much kinetic energy do we need to give it in order for it to be able to make it through the loop? We already agreed that in order to make it through the loop, it needs to have some kinetic energy here, right? The gravitational potential energy is going to be the same at both of those points, right? It's at the same height there, so the UG here is equal to the UG final there. In fact, if you wanted, you could define this line as height 0 and just say it doesn't have any gravitational potential energy at all. Yeah, it does have gravitational potential energy, but the change in gravitational potential energy from there to there is 0, and that's really all that matters. And so really what needs to happen is we need to make sure that the kinetic energy, which is going to need some kinetic energy, the kinetic energy at this point is equal then to the kinetic energy at that point. So the question then becomes, how much kinetic energy does it need at that point? I'll give you a hint. It has something to do with circular motion, right? What would happen? Think about this. What would happen if the ball was going too fast? If I had too much kinetic energy, right? If I had too much kinetic energy, it would be speeding down here. It would just go through the loop and it would go on. But what would be happening right here? Okay, we talked about that if it didn't have enough energy, it would kind of fall off the track. It would leave the track at that point. If it had too much energy, then I'd have the force of gravity pulling down. And because it's going so fast, the track, there'd be a normal force of the track that would also be pushing down, right? The ball is going too fast for it to go in this circle with that specific radius. Hopefully you're starting to make some connections to circular motion here, right? In order for it to go in a circle with approximately a radius. Now remember, the diameter is 10, so the radius is 5 meters. Now we can start looking at that because we need that to answer the question. In order for it to go in approximately a circle with a radius of 5 meters, at this point, I need a specific amount of centripetal force. Right? Now, if I'm going too fast, then I'm going to need more centripetal force in order for that to happen. Here, let's look at the equation. We know that centripetal force is mv squared over r. Now, if you're looking in your formula packet, remember this is not there. What is there is centripetal acceleration, which is v squared over r, and we know that force equals ma. Right? So mass times the v squared over r. So centripetal force is mv squared over r. If I'm going too fast with a given mass and given radius, I'm going to need a larger centripetal force. So what is the smallest centripetal force that I can use here? Well, thinking about the fact that at this point, the centripetal force is the combination of the normal force and the force of gravity, the smallest centripetal force that is possible is the force of gravity, right? If I had zero normal force at all, if I was going just the right speed so that at that point there's no normal force at all, if I went any faster, the normal force would have to push on the ball to keep it within my circle. If I had no normal force at all, that would be the minimum centripetal force that is possible. I can't change gravity. Gravity's going to be there no matter what. If I go too slow, then I need less centripetal force, which is not possible. Gravity's going to be bigger than that, and it's going to pull it down rather than allowing it to go in a circle. So my centripetal force here needs to be the force of gravity. So the centripetal force is the force of gravity. We know that the force of gravity is mg. So therefore, we've now set these two equal to each other, and we can say mg then equals mv squared over r, which means the mass doesn't matter, right? I divide both sides by mass. Those guys both go away, and I'm left now with g equals v squared over r. I know g on the surface of Earth, g is 9.8. I'm looking for the velocity. Why am I looking for the velocity? Because I'm looking for kinetic energy, right? And kinetic energy depends on the speed. So if I can find the velocity, if I can find the speed, I'm good to go, right? And then the r, of course, is that 5 meters, half of the 10-meter diameter. So at this point, I take my fancy calculator, and I go, let's go 9.8 times 5, and I get 49, and then I square root that 49. The square root of 49 is 7. So I get v equals 7 meters per second. How about them apples? Right? Now this is only looking at that point right there. Right? I'm not looking at any other point in the circle. Number one, because those other points are not important. Right? In this situation, the only forces are gravity and the normal force of the ramp. There's no friction. So therefore, gravity is included in my gravitational potential energy, and the normal force is always perpendicular, so there's no work being done. Energy is being conserved. That's what we've been talking about since the beginning of this problem. Okay? We end up getting the speed, and so with the speed, I actually now have the answer to the question, right? The question was, how much speed do I need to start with in order to be able to get all the way through? This is the answer, because therefore my 1/2 mv squared here needs to be equal to my 1/2 mv squared there. As the mass is the same at both points, the speed has to be the same at both points, and so therefore I need to start my ball with 7 meters per second. All right? There you go. That answers the question. Hopefully that was helpful, talking through the principles. If you have any questions, just send them to me either in Google Classroom, or if you're not in my class, in the comments below. I'm happy to help you out and answer any questions you might have. We'll see you next time.